Let's do another example. We have a random variable x. It's normally distributed with mean 950 and variance 100, right? So we're using this notation. X is normal with mean mu is 950 and variance is 100. Okay, good. You have to find the probability that X lies between 950 and 947. Yeah, X lies between 947 and 950. The method remains a pretty standard method when we deal with normal distribution, right? From your X, you need to convert it to a Z, right? Using the standardizing procedure, X minus mu over sigma. So that's what I've done here for you, okay? X minus mu over sigma. So this thing has become Z, as you can see here. So doing this on the left-hand side and the right-hand side of X, a 947 minus 950 over 10. On this side, we have 950 minus a 950 over 10, and you will get, you will find that you're finding the probability that Z lies between negative 0.3 and 0. Again, you're going to find the probability that Z lies between negative 0.3 and 0. So we'll resort to your, this is your normal curve for Z. And we have got 0 here. And we have got negative 0.3 on this side. We're looking for this probability. Yeah. So look up your tables or your calculator. You know, this value here is 0.5. Okay. This value here is 1 minus 0.6179, depending on which table you're using or which calculator you're using. So this value here, this area here, I repeat, this area, let me, if I can just, no, I don't think I need to shade it, right? So the area to the left of negative 0.3 is 1 minus 0.6179. The area to the left of 0 is 0.5. So you take 0.5 minus this and you will get your answer. Okay. Just take note of this. This is not hard. If y equals to ax plus b, and if x is normal with mean mu and variance sigma squared, then your expected value of y is also normal. Okay. Y is also normal. Okay. Y is also normal with mean a times expected value of x is mu plus b. That's what you see here. So y is normal with mean this, and variance is easy. It's just, you know, a squared variance of x. That'll be a squared sigma squared. Okay. So let's move up and look at another example. We have x is a random variable with mean 10 and variance 4. What is the 12th percentile? Not hard, right? So we are looking for the percentile. If you want, you can write it like this. Okay. 0.12 percentile, 0.12. Okay. So as usual, change x to z. So on this side, you have to change. I've used a for xp, right? So you can write xp minus, what's mean? 10 over sigma squared is 4, so sigma will be 2. Okay, sigma squared is 4, so sigma will be 2. That's what you see here, and that's equals to 0.12. So draw a normal curve, place your probability here, 0.12. It'll be on the left side because this is z less than, is this value here, 0.12 is less than 0.5. So it must be on this side of 0. So this value here, you pick up from your tables or your calculator. So a minus 10 over 2 is negative 1.17. Okay. Use a calculator and you'll get a 7.66. Okay. Next, I want to talk about the normal approximation to the binomial distribution, right? So let's learn it using an example and then we'll formalize it, yeah? So we have the normal approximation to the binomial distribution. So first things first, yeah? I have an example here. Maybe let's talk about the example and then let's read the example and see what we need. Say we have the following. 10% of the students in a college are colorblind. Okay, 10% of the students in a college are colorblind. A random sample of 818. 818, okay, in a random sample of 818 students, what is the probability that at most 100 students are colorblind? Okay, what's the probability that at most 100 students are colorblind? So, um, first, we are talking about a binomial situation. You must appreciate that, right? This is a binomial problem. Why? You're either colorblind or you're not colorblind. So it's two outcomes. Each trial has two outcomes. And the probability of success, because we're dealing with 800 of them, and the probability of success of being colorblind is how much? 10%, so 0.1. So we have a, let me write it here. Our n, the number of people we're looking at, 818. The probability of success is 0.1. So we can write x is a binomial random variable with n equals to 818 and p equals to 0.1. Now, this is a binomial problem. We are looking for probability x at most 100, right? So at most 100. So it can be 100, it can be 99, it can be 98, whatever, right? Okay, at most 100. So if you're going to use the binomial formula, this is going to take a lot of work. Okay, if you're going to use a binomial formula, this is going to take a lot of work. And even if you have tables, right, some of the tables might not have these values of n, right? 818. So we use the normal approximation. So to use the normal approximation, number one, okay, to use the normal approximation, number one, you need mu. And mu will be equals to, what's the mean of the binomial distribution? NP. So work that out first. N is 818, P is 0.1, you'll get 81.8. Then you need the variance, which is NPQ. So you take, you take 818, and then you take 0.1, and then you take 0.9, correct? And you'll get some number here, which is 73.62. That's the variance. So your normal distribution, the normal distribution that you're going to use, let's call it Y, right? The normal distribution that you're going to use has a mean of 81.8 and a variance of 73.62. What are we asked to find? This is the question. Probability x less than 100. What is x? X is binomial. So x less than or equal to 100 is the same as this one here, right? If you see three lines, means identical to, right? Same thing. Less than or equal to 100 is the same as less than 101, correct? Okay, because x is discrete, yeah, binomial. So x is less than 101. So the midpoint will be what? This is 100 and this is a 101. So the midpoint will be 100.5. I'll tell you about this in a minute, but just follow along, right? So this is the question. I rewrote it as less than 101. So the midpoint is 100.5. I will work out, because I'm using the normal approximation, I'll work out the probability that y is less than 100.5. That's from here. The midpoint of this and this, okay? 100 plus 101 divided by 2. So this is what you'll work out. Okay, this is what you'll work out. Let me move it up a little bit. Okay. Okay. Then what do? We look, once you get here, right, you're done. Just change your y to z, right? You change your y to z, 100.5 minus the mean of y. What is the mean of y? 81.8 from here. What is the variance of y? 73.62. So the standard deviation is the square root of that. That's what you see here. So change your y to a z. Look up your tables. Okay, look up your tables. This value here, this is 2.179. This area is given the tables as 0.9854, and we are done.